Hey everybody, it's me Yunhan, and today in this video I'm going to be doing a challenge given by this person called the Master of Entropy. He gave it to me in a comment, and if you want to suggest any challenges, feel free to comment so I can do it for you. So anyway, here's the challenge that he given. It was the integral of the natural log of x to the fourth plus 5x to the third plus 11x squared plus 11x plus 4 dx. This is a big integral, and without this natural log it will be way easier because we can just use the power rule 5 times to get the answer. But in this case, this natural log is not allowing us to do that. So over here I'm gonna use integration by parts. So I'll assume u is this whole thing here. I'm just gonna write this as y. So I'm just gonna put u is y. Yeah, I'm gonna make this whole thing y. U is y and dv is dx. So du is the derivative, which is basically the derivative of the inside function over the inside function. Yeah, blah blah blah. Then we'll have v is x. So, and now using the integration by parts, we get x natural log of x to the fourth plus 5x to the third plus 11x squared plus 11x plus 4. Then we subtract the integral of x, and then now this is the one that we need to find, but it's very simple. It is 4x to the 3 plus 15x squared plus 22x plus 11 divided by x to the 4th plus 5x to the 3rd plus 11x squared plus 11x plus 4 dx. So this is the integral that we have to find next. So I'm just gonna erase all this for a moment. Okay, so to find this integral, first we have to do some simplification. 4x third. In fact, I'm not even gonna put the integral here yet, because I'm just going to focus on the fraction itself. 4x cubed plus 15x squared plus 22x plus 11 all over x to the 4th plus 5x cubed plus 11x squared plus 11x plus 4. This is a really big fraction, and if we're going to integrate this, we're going to have a bit of a problem unless we simplify it. So we need to simplify this. Firstly, let's try to factor both of this, not the x, because we can't factor it. So factoring both of this. Okay, let's look at a cubic function first. Let's find a root for this. Experimenting, we know that x equals to -1 gives us a solution, because -4 plus 15 minus 22 plus 11 is a solution. It's equal to 0. Yeah, it's equal to 0. So from here we know that x plus 1 is a factor. So therefore we put this over here. Yeah, and we're gonna do long division on these polynomials. This is gonna get quite a long video. And this is x plus 1. So from here, we'll have 4x squared. Then we'll have 4x cubed plus 4x squared. We subtract that from this part, and we will get 11x squared. From 11x squared, we have to bring down the 22x. So therefore from here, we get plus 11x. So we get 11x squared plus 11x. Subtracting, we get 11x. Now we bring down the 11 here, and we see that it indeed is a root. It's a factor. So we get no remainder after this. So this is the factored version. Okay, so I'm back after switching markers, and I'm gonna write this as x plus 1. Then we have the quotient 4x squared plus 11x plus 11. Now we need to factor the bottom. Again, it shows that -1 is a solution, because 1 minus 5 plus 11 minus 11 plus 4 again is equal to 0. So we're going to factor this thing up, and I'm going to put it here again, doing long division as before. So here we put x plus 1. And remember, it's x plus 1, not x minus 1. Because minus 1 is the root of x plus 1. So anyway, so here we're going to have x cubed. So we're going to have x to the 4th plus x cubed. Subtract that, and we get 4x cubed. Then we add this down. Then over here, we're gonna have 4x squared. So 4x cubed plus 4x squared. And we're gonna have 7x squared. Putting this here, we're gonna have 7x. So 7x squared plus 7x. Subtract, we get 4x. Then 4x plus 4, we see that this is indeed a root again, because we have the same thing as before, no remainder. So I'm not gonna stop here. Here's why. Because, okay, first I'm just gonna note that this is a factor. Then we're gonna have something else here. I'm gonna factor this quotient. Okay, so I'm factoring the quotient, and this is why, because we already have this 2 here, so we can actually cancel these out. And I just want to factor this again so it's easier. So let's find a root again. -1 is a root again, actually, because -1 plus 4 minus 7 plus 4 is 0 again. So yeah, so we know there's gonna be an x plus 1 there, and I'm not gonna write it down yet though. So let's just do the long division again, and this video is getting long already. This is x to the power of 3 plus x to the power of 2. Subtract that, and I'll get 3x squared plus 7x. From here, we have 3x. Then this will become like this, and we get 3x here. We subtract that and get 4x. Then lastly, we just put a 4 here. You get 4x plus 4, and again, finally, no remainder. And this cannot be factored. It seems quite trivial why it cannot be factored. So anyway, this is the result that we have for this fraction. But we're not done yet. Remember, there's a lot of steps to this integral. And again, I'm going to go through them step by step. And like this one, I've already done. So now to integrate this whole thing, dx. We're gonna have to use long division again. Actually, no, we don't. But firstly, I'm just gonna write this down simpler. It's x 4x squared plus 11x plus 11 over x plus 1 x squared plus 3x plus 4 dx. So from here, remember I said I was gonna go through all the steps. No, I'm not going to. I'm just gonna show that this is just another fraction. And I'll just instead show that if you use polynomial long division, you'll get this. So from here, it's just really easy. You just have 4x minus the integral of this. This is honestly a monstrosity, and no, I mean the first integral. Like with the natural log, everything gets very confusing very fast. So this is the one we need to find, and I'm gonna erase everything and write the whole integral again. Okay, so the way to evaluate this integral, it's quite simple. But it requires some intuition. So I'm gonna do some partial fractions first. And this is gonna take a while. So anyway, this whole fraction, I'm not even gonna integrate it yet. This whole fraction can be expressed as partial fractions. A over 1x plus 1 plus bx plus c over x squared plus 3x plus 4. Now here, we're gonna do the normal partial fraction way, and we're gonna get ax squared plus 3ax plus 4a, and then we'll have, we're gonna have bx squared plus cx plus bx plus c. Oh wow. And all of this is 5x squared plus 17x plus 16. And this is wearing my marker out. Goodness me. So anyway, from here we're gonna have to equate the coefficients and solve the simultaneous equation. So this is a plus b equals to 5, because we are equating the x squared coefficients. Now equating the x, 3a plus b plus c. 3a plus b plus c. Yeah, 3a plus b plus c is equal to 17. And lastly, equating the constants for a plus c is 16. This is hard. It's a big simultaneous equations that I'm gonna have to do, but I'm not gonna show all the steps. And I'm just gonna show that the solutions are a equals 2, b equals 3, and c is equals to 8. These are the solutions. And oh wow, it came back. These are the solutions, and just plugging it into the partial fractions. I'm just gonna erase these. Just to know them. This is 2. This is b. This is 3. And this is 8. Yep, that's the partial fraction. And now I'm just gonna integrate that whole thing. Well, it's quite simple. For the first one, it's trivial. 2 over x plus 1 dx. To get the integral, I just need to first pull out the coefficient 1 over x plus 1, and before I even write x plus 1, I'm just going to use the U-Substitution for x plus 1. So du is dx, and we get 1 over u du, thus giving us 2 natural log of u plus c, but I'm going to ignore the c now, and thus we get 2 natural log of x plus 1. And the second integral, it's the one that we need in intuition with. The second integral, we're gonna need, okay, first I'll write down the second integral. For this second integral, here's the intuition. I'm gonna write this as 3/2 multiplied by the integral of 2x plus 3 over x squared plus 3x plus 4 dx. And I'm just going to add 7/2 multiplied by the integral of 1 over x squared plus 3x plus 4 dx. So that's basically what I'm gonna do, and I'm gonna solve this individually. Here, you're gonna have 3/2, and look at this. This is the derivative of this. This is where the intuition came from. So this is quite simple. It's just natural log of x squared plus 3x plus 4. And I'm not going to put any parentheses. I'm not going to put any absolute value, because this is always positive. So now I'm just going to solve this one. Okay, so rewriting this, we get this. So now I'm just going to use U-Substitution. U is equals to 2x plus 3 over square root of 7. And I'm going to leave the square root of 7 on the bottom. Okay, anyway, we get du to be equal to 2 over square root of 7. And, dx. And then we'll get dx to be square root of 7 over 2 du. And I'm not going to show you the steps, but it's easy to show that this is just 2 square root of 7 over 7u squared plus 7 du. So from here, we are just gonna start factorizing, and actually we just make this into 7u squared plus 1. Then we can bring this whole thing out. We can get this, to get 3/2 natural log of x squared plus 3x plus 4 plus square root of 7, and arctangent, because of this u squared plus 1, arctangent of u. And what's u again? 2x plus 3 over square root of 7. So that's our integral, and I'm not going to put the c yet. I'm going to put it in the final integral. And so now we can finally find the value of this integral. So first we did recapping. We first found by integration of parts this part of the integral. Then after that, we had another integral that was subtracted. But then instead of, I'm going to expand out the brackets. This is going to be minus 4x plus the integral. In fact, it's another integral, ... And this integral, we have found out that it was split into 2 other integrals, which the first one evaluated to 3/2 natural log of x squared plus 3x plus 4 plus square root of 7 arctangent of 2x plus 3 over 7. Then finally we had another one, which was 2 natural log of x plus 1. Now, let's see. And this is our final answer. This is the whole answer. And thank you for watching. Subscribe.